Hey, John here. So this is the Rev3 board that I've been using to run all my tests on when I talk about the Z80 Retro project that I've been tinkering around with for the last, I don't know, 9 months or so, okay? Now, some of you may have noticed that with the Sharpie I wrote Rev4 on here. This is a Rev3 board, but I made it into a Rev4. I use this to test the Rev4 design changes by going in here with an X-Acto and rerouting this wire here. It's the main issue that I had with Rev3. You may recall the printer control line was being driven by a pin from the UART here, the SIO. I chose the wrong pin, and the signal can glitch from time to time. But honestly, it does so, if it even does so, it does it in a way that doesn't affect my printer anyway, in the least. I've never had any trouble with the Rev3 when I did my printer testing. However, it's just not right, so I wanted to fix it. I couldn't sleep at night. So I made the modification. I've been testing it many times on here. Then I worked it into the schematic, and that became part of reversion 4 release candidate number 1, which is on the GitHub site, marked as a pre-release of this system design. Now, along with that change, there is improved grounding in the power supply connection over here, which I've never had trouble with, but why not? While I was in the messing with the board anyway. And I also added some terminating resistors on these outputs for these oscillators to hope you kind of get rid of some of the overshoot and ringing on the outputs as it winds around the board. Again, I've never had any trouble with it since last September. 9 months of use, and this board was running down here in the old basement for week after week after week, just powered on 24/7 for several months, and I never had any issues. But I just can't help myself. While I'm poking around in there, I added the option, I should say, to put some terminating resistors up here on the end of the lines of these outputs here. All right. So that's the main issue with v4rc1. The design I know works because I already tested it here. The only thing that could really go wrong would be if I, did something wrong to the copper on the PC board when I made that design. So this just in, maybe 3 months ago. It's been sitting around for a while. I've been busy, we all have day jobs, right? So I haven't had time to really actually put this together and run some tests on it. So this is the first real release of the programmer board. I've never actually built the actual release because the one that I had, again, just like this board here, that changes from the prototype, or say version 1. This is marked as version 2, if you can see that at this zoom level here. The version 1 is pretty close. What was wrong was the pull-up resistors on the reset line, which drove me nuts. I had a whole video on what was wrong with that and why. And I fixed that in this board. So I'm going to build one of those, make sure that the copper's right before I tell everybody, hey, it's great. I'm not going to put my stamp of approval on something unless I see the thing working. And this is, of course, the Rev4rc1 board that I ordered at the same time. So let's go ahead and do this. Why not, right? Now, among other things, I've got another idea on, 9 months ago, I did a video on how to solder in the SD card connector, which is kind of tricky. It's a surface mount piece, and if you're really not into that, your first try, that's not the easiest thing to do in terms of surface mount. But I think I ran into a problem last fall because of the way this socket is designed. Let's look at this for a second here. So if you go back to last fall, this pad right here, let me zoom in a lot here. Okay, so here is a closer shot of the situation here. This pad here was the one that drove me nuts. I thought this one would too, but it didn't. These down here are similar. And what these are is they are the joints that solder onto the metal case of this connector itself. Okay, so the thing sits down like this. All right. And this corner here has a little metal tab underneath here. I'll show you in a minute, as does this one here. And it sits on these two tabs there and there. And when you put the soldering iron in here, you can sort of reach in underneath a little bit and heat up the metal case of this and the pad down here at the same time. And it's really easy to solder the thing in. Plus, there's not a lot of metal here to let the heat flow and dissipate. You can do that one quite easily. Same with the one over here. But the other two, the pad up here, I had no end of problems with. And I didn't really think about it that much other than to curse a little bit off mic. But look what's going on with the way this thing is designed. There's no pad here. You can see this little pad there and this little pad here. Well, if you stick it like I did on here like a dingus, like I was, and you think you're going to heat up the metal here, which I did, and the solder would adhere to the case, I was thinking, like a dingus without looking, that there was a little pad underneath here that would heat up this down here, and obviously there is not. Now, this pad has also got thermal relief around it, as you can see here. So even if I put the soldering iron down on the ground plane and heat up the whole area, that pad will not heat up. So this is why I had some trouble. I'm pretty sure that's why. Same thing could happen easily over there. So this time, what I'm going to do is I'm going to put a little dab of solder on here before I put the connector on there. And the connector will sit up on top of that. It'll be in a wedge. If I hold this up sideways like this, that connector will sit up on top of these little solder bubbles up on an angle like this. And that's okay for starters. And up on those bubbles, I will align it like this, and this edge up here will be lifted up in the air. That's okay. And what I will do is I will tack solder on one or two of these pins here, in which case I'll have it'll be levered up in the air. While it's up in the air, I can bend these ever so slightly while I can reach in and heat this up and heat up that little bubble that's already then soldered onto the ground on this pad, because there'll be a little hump in there. I'll be able to get the iron in there. While the iron's in there, I'll heat this up, and then when that happens, I'll push down on this, and it will then set down on the board. It'll be a little bit crooked, and it'll put a little bit of strain on this pin, which I will then come over here and reflow that to relieve the stress that's on that pin. Do the same thing on this other side. And thinking about this, because it's going to wobble around while I push down at it, I would only want to tack one single pin down in order to get all the, the angles and the forces on this that will be temporary while I'm playing these games all worked out. Now, none of this would really be a problem if I just used hot air to put this down with a stencil and some paste, because the whole thing would go down at once and everything would be heated up. It might also work with a hot plate, or a combo of a hot plate and the hot air, right? So I'm going to try that, and I think it'll relieve my headache that I had with this pad over here. Even the second time I did it, which was on this board here, I didn't have that much trouble. You can see this is not a big mess like it was 9 months ago when I soldered this one on. But it did take a little bit of effort and a long time of heating this thing up in order to get those corners down on that connector. So that's the other big excitement about this particular build, at least for me, to take yet another swipe at this connector. As they say, third time's a charm, and I hope that is going to be the end of it, because I just ran out of those connectors. Let's go ahead and remove some of the heat from this sacrificial cutting board here. It's not going to be suitable if I heat it up while soldering iron on it. All right, so I got this is one of these Hackaday things that you see everybody has, the cheap Hackaday iron here. I got it set to 675 degrees Fahrenheit. Don't spare the heat on this one, just in case you want to wonder. There I go. Some solder on that pad. I'm going to go ahead and do this. All right, there we go. Now, this pad up here has a little wire that goes onto it. That's, in fact, you can sort of see it sticking out the side here. A little visually noisy right there. You can see that pin right there. That's a signal pin, as is this one over here in this corner up there, which lands down there. Those are really, those are much easier to solder on than these because of this whole thermal relief problem. All right, I'm not going to pre-do those because there's no reason to. The more of these that you put solder on ahead of time, the harder it's going to be to get the thing on there right. It's just going to be a big pain in the bungus. You know what might also be a good idea is if I pre-tin this connector on the edges here. And the reason I think that's a good idea is because of the, otherwise you'd have to put a lot of flux in here and it'd be a big mess. And the last thing you want to do is get flux on these pins because it's going to be almost impossible to really do a good job of cleaning it out. I feel as though, I mean, I flooded it with alcohol, it's going to drain. And even if you do make a mess of it, okay, and if the only thing you got on there is like this, or you know, some other parts that are not really going to be a problem, if you do so, you can throw this board into a little you know, a little vat of you know, a tray of alcohol and just leave it sit there overnight and let the alcohol dilute and dissolve the flux and everything else that it wants to, and then drain it off and air dry it out, and that'll probably get rid of all the flux that ails you in there anyway, if you need to go that route. But I am not going to do that. I'm going to go ahead and you know, use this to hold on to it maybe. I'm going to pre-tin this thing here. Let's see if I can get it to hold up. This whole thing will... It's probably a terrible idea, but we'll find out. Why not? Let's you know, take a risk once in a while, right? It's what makes life worth living. Oh yeah. Okay, so let's go ahead and tin this. Is there any on there? All right, go do this. Great, I got it on the top. Oh, that is the bottom. That's about right there. Good job. All right, so this is going to be okay. Get some solder on there. Okay. Does that look okay? Is that enough? Well, somehow I think I should have a little more than that on there. Oops. Come on. Now I don't want to grab it this way, by the way, because these pins here are really sensitive, and if I ram it into the you know, the jaws of the pliers here, I could bend them, and I don't want to deal with that. Now these have a little spring in here too, which is making this thing want to open up all the time. Let me go get another one that doesn't have a spring. Normally the springy ones are the good ones. Here's a cheapo one. Get yourself a crummy pliers for this task. Alrighty, there we go. You can still see it's tinned. I'm sure it's fine, but the 10 tons of overkill in me wants to see some more on there. And yes, I'm aware of the fact that I just said more on, as in moron, there, which might be the problem that I'm going to run into. And that is that I may manifest myself in the form of a moron by putting too much solder on this thing. Okay, so let's go ahead and flip it over and do the other side. I mean, before you start putting all the sensitive pins down, you can always just take this thing back off, clean it up, and start over if you really want to. All right, there's some soldering on there. And normally you wouldn't want to put the solder on the iron first and then the iron onto the work, because what you need to do is make sure that there's flux on the work, right? But I could see that there was flux on the tip of the iron as well as there. And that's what that is, by the way. I think there's more flux on there than solder. But the fact that there is solder on it at the bottom there, at the very edge of that lip, is what we really need. All right, so there's a little groove of solder on there, which is really enough to do the job. And, you know, in order to get, you know, anywhere near a visible blob on there, which is probably going to be too much if I go that route, I'm going to have to hold the iron on here quite a while in order to heat up, because it's going to heat up this entire metal case before there's enough heat there for the solder to really adhere. And give yourself a little bump on there. I think that's what we want, though. A little bump on the bottom edge. That's fine. All right. Yeah. Okay. Let the frustration begin, right? Let's see what happens here. I can barely see it with my own eyes. Got to use the bench camera here. Okay. There we go. All right. Let's see what happens here. Getting lined up on there. All right, so they square it up. Okay, so remember, the only solder on this entire thing right now is on the board and the side of the case here, as well as on the board and the side of the case over there. And there's very little solder on there. I think, you know, the problem with me just simply soldering it down to the board right now would be that if I don't get these lined up right, if it shifts at all while I'm messing around up here, I'll never get these pins on right, okay? So my gut tells me to go ahead and, like I said, tack down one of these pins over here. Oops. So that it holds this end of the socket where I ultimately want it to be, so I don't accidentally, you know, spin it around or anything while I'm clowning around with those other footprints up here, the pads, I should say. So let me get it lined up. Well, actually, what I should do is go ahead and just put one of these pins on. It doesn't even need to be accurate, because then I can align it. Boy, I need 5 hands practically. Let's go ahead and put a little dab on the iron here. See if I can get this on there. It might need to have some flux be put on it. In order for this idea to work, I may have to pre-flux the footprint pads on the board here. I do. All right. So that pad is definitely on there. Okay, so that'll hold it. And it'll help me from rotating it too much. All right, so I think I'm going to go ahead like that. Now I should be able to just put the iron tip in here like this and reflow the solder that's in there and burn my finger. That's a good idea. Kind of push down on it with this tip of this tweezers. And do what I was trying to do 9 months ago. And that is to get the pad underneath it heated up, as well as the side of the connector, and all this done at once. Let's see what happens. It also may take a while for it to cool down enough for the solder to solidify. So don't take the you know, your tweezers off too soon. Now let's see if it moves. It's not soldered in, and it's not soldered in, people. And it seems to be more crooked than when I started. Oh my gosh, this is the bane of my existence here. These stupid connectors. What this thing? Oh. Okay, let me try again. Stupid thing. Now I bent it too far. You know what? Need to get some solder on this tip here. Maybe. There we go. Why am I having a deja vu from 9 months ago? It's deja vu all over again. To quote Yogi Berra. Right, Please solder on. This has got to be the worst thing. This is the hardest thing I've ever had to solder on, you know, these surface mount things. I can usually, the 0402s are a little bit small for me, but the 0603s I can do, 805s easy, and other such things. But these dumb edges of this connector here has just been a problem. Now, please. All right, I think we got it. Ooh, that's a little toasty. And ooh, that's a little crooked. I might want to reheat it now and move it over to that way a little bit. It'll be all right, but it just doesn't look. It doesn't look perfect. This is this is like the worst thing to do. It's on. It's perfectly serviceable, but I'm gonna mess with it. This is the beginning of the end of this board. And perhaps the end of this whole connector. I don't know. Let's see what's going to go on here. It shouldn't take long to reheat it. And once you get the solder on there and it's all connected together, even if you reheat it, it shouldn't become too much of a problem to clown around like this. There we go. There we go. And is that straight? Is that straight? Is it looking straight? Oh, it wants to just kind of move around. Come on. And it's crooked again. Dagnabbit. So what I need to do is push down on it and over at the same time. And I don't like the tip of the tweezers for that job. I need to use something like the fat base of this thing. There we go. There we are. Is that good? Okay. All right. Now, I'm going to relieve the stress in this pin now by simply just reflowing it. It probably won't move at all, but I don't like, this is just a bad idea to leave stress in any pin on something like this that you soldered on and then moved, okay? Now, I'll do that again because when I do this one, it's going to move ever so slightly. Again, basically almost none. Again, I'm going to put some soldering on here. The reason you want to put a little solder on here is not because I want more solder on the case of this. And as I explained 9 months ago, what the solder does on the tip is it increases the surface area of the hot tip that's coming in contact with this metal case here and allows the heat to flow into the part and underneath and into the pad and so on. Well, it's not about getting more solder on the joint. It's about getting more surface area between the iron and the device and its pad. So hopefully that's enough time. I have no real indication as to whether it is or not. But after you let it cool for a few seconds, what we can do is gently grab the corner of this and pull up on it, like a millimeter. Don't yank on the thing. Just ever so gently pull it up. Just see if it wants to fall off of the board. And I think the answer is no. Yeah, no, it's on there. And that will not come up when I tugged on it. So let's go ahead and try this one again as well. See if this one wants to come up. There you go. That's how you do this. You have to put down a little bob of solder down in there first. Well, the way this camera is on there, it looks like a kind of a cold joint. Let me mess around with a focus on here a little bit and see if we can get a good look at that and see if it's good or not. And then we go zoom in some more. How much more? That's about as far as I can go with this camera, with the way the lens is mounted on here today. That's looking pretty good. What about this one here? Yeah, that's looking okay. It just has a little cusp sticking up from when I pulled the soldering iron back up off it. If you really want to get rid of that, you can just remelt it a little bit. Okay, that was what was throwing me. That's what made it look like a cold jar. Oh, look at that, a nice fillet on there. That's nice. And by the way, I believe it's pronounced fillet and not fillet. A fillet is what you do to a fish. All right. Okay, that's good. Okay, we have a fillet, as it were. I'm sure I mispronounce a lot of words all the time, too. It's the bane of any YouTuber's existence. I wonder if I'm saying this right. I usually Google some of the stuff if I'm not really sure. And you know what bugs me? It still looks crooked. Ever so slightly. But you know what? I don't care. It's staying that way. All right, so let me get these pins on here. And I'm not putting any extra flux on it. This is going to be good enough. This is going to hold down. It will, I think the solder will flow and the pads will be there. What I should do is use smaller solder for these pads because it'll have a higher percentage of flux in this is a rosin core solder. It's a 6040 rosin core. But just like Daddy and Grandpa used to use when I was a kid. Yeah, just don't put it in your mouth because it has lead in it, right? Oh, look at that. Nice. Go ahead and solder up these pins. Do. That's got a little bit of a bridge there, maybe. Okay, the light glare is really making this difficult to see. Uh-oh, that one's definitely got a bridge. Well, a couple ways to get rid of these things. I was just talking to somebody in the YouTube comments on one of the videos about how everybody goes nuts with the flux. Tons of flux when they don't need it. And the solder wick, which I can never really get it to work right. So what I do, I got two techniques that I use to get rid of extra solder. And I may have to use them both right now. One of them, the simple one, is you kind of go in there like this. And if there's too much, there's a couple of things you can do. You do like just keep drying off the iron and go back and kind of comb the pins with the tip of the screw of the iron. And I don't have a super duper pointy tip on here either. Those don't ever work for me. I can't get enough heat out of them. All right, it's perfectly fine to melt 2, 3, 4 of these at once. That's not why I'm suffering from this getting this bridge over here. The reason that's there is because I have too much solder on the tip. Yes, having a smaller tip would reduce the solder. Blah, blah, blah. Save me the comments. The bottom line is you can drag across here and dissipate the extra solder into the other pins. Or one of the things I like to do, and this is pretty sloppy, but it works great, is you heat up and melt the solder, okay? And when the solder's melted, you can tap the board like this, right? The iron's on there, it's melted, and just tap it. And all the liquid solder is going to go flying into here. Now, when I did that, it also slid forward, so it's like all over here. But the solder, point is, the solder goes away. You have to clean it up off your work surface so you don't get it on something else. But you can get rid of the extra solder that way quite easily and very effectively. All right. Now, I'm going to go ahead and reflow these things and make sure that they're just, ducky. And again, I got a lot of light glare on here today. I got a different light in the shop here. Maybe this is not so good. So I hope this is the ground pin because it wants to have this bridge over here. Oh, yes, it is. That's why there's a via there. Okay. So you can mess around with these if you want to clean them up or whatever. When I'm done, I usually take a... I can't find it. I'm panicking. I got a 30x loop, one of these things. I think I've mentioned this in the channel before many times. And you get your eyeball way up in there and give it a good look. Yeah, it's not too beautiful, but it's on there. All right. Now, what's not beautiful about it is it's got little hairy little flecks of solder. So another one of the things that I do if I don't use hot air, and usually the final pass, you just heat it up with hot air. I go like this, and what I'm doing, if I look at it sideways here, what I'm doing is I'm going in on the pin and then up and around the pin, and then I release this way. And what happens is, if there's too much solder on there, what it does is it moves the solder and it leaves it sitting up high on the pin instead of down here where it can go out and short out into the nearby ground plane, which is pretty close to these pads, right? So one of the things you can do is kind of go up like this. So, and again, what we're dealing with is we're moving around ever so slightly the smallest amount of solder, almost negligible amounts here, but just a hair. And you can let it sit up high on the pin instead of down here at the base. So some of the nastiness on the camera that the camera's picking up is the reflections from, there's a little bit of flux sitting on there, okay? So that's on there pretty good, even though it doesn't look so good due to the flux on there. So you take yourself a nice, a bit of a toothbrush and brush it off, and that would get rid of the extra flux, okay? So that gives me my pins. The back of this connector is down. I need to now solder on these pins here, and we're golden here, right? After that, I am going to, because I have it, I'm going to hit the whole thing with some hot air and clean up all the fillets around these pins just so that they look better than they do right now. Okay, so for these front corners here that don't already have solder on them, what I'm going to do is I'm going to reach the solder iron in underneath here like this and heat up that tab on the inside there, okay? And as you can see, like the whole thing's already kind of shifted a little bit to the left here. Actually, it's not too bad. Actually, I can get easily in here. This pad sticks out a little further than that one does there. The point is I can take my iron and I can heat up this pad underneath here and know that I'm getting heat onto it. Okay, that's going to work nice. Mostly because I think it's a little bit too far to the left. So let me get some solder on the tip once again to maximize the amount of surface area between the iron and the part. Okay. So as it heats up, this yeah, there it goes. The solder will melt without touching the iron. So I just melted it by touching the pad. So I know that's hot enough right now. And I know that there's solder in there and underneath it. I may have to take that loop and take a closer look at that to know for sure, but it sure seemed that way to me. And the answer is absolutely yes. There is solder in it and underneath it, but it's ever so slightly lifted up in the air. So what I'm going to do is reheat it again and make sure that that this is pressed down and seated against the circuit board, which I didn't do when I was just poking around in there a second ago. So now you can clearly see it's melted in there and it's down because I'm pushing on it. This is about an eon of time to spend playing around with this connector here. Let me see if I can see this here. The loop, and maybe I can get a good focus on it here with the camera. All right. I don't know how close I can focus. Will that work? Yeah, that's focused. Oh, well, only I can hold it steady. All right. So you can sort of see the fillet right along the front there. Let me give me a, oops. You can see the fillet right here, right in the front, right in there. Okay, so that's on there too. So if I grab it with this tweezers here, I keep the thing in focus, and I push up on it ever so slightly at first, away from the PC board. It's not lifting up. This one I did not solder on yet, so like it would do this otherwise if it's not soldered on. If I can get the pliers in there, right? So this one is going to lift up a little bit. All right. Actually, the pins are really, yeah, you can see how that one's lifting up ever so slightly right there. So that's what this side would here would do as well if it was not soldered down. All right, and it's not lifting up. So I think we're good. So all we need to do now is this other corner here, the pin there and the pin there, and we're done with this socket. And this one is the third time is a charm, I guess. This one's actually soldered on correctly, which is, you know, not bad. 9 months it took me to get this thing on all right. All right. So where are we at here? Come on, get in there. I'll do the same thing I did on the other side, since it worked so well. All right. And again, there's not a lot of metal on the corner here, so when it is hot enough, this should just melt from the other side of the connector case here. Right, of course, they could be flux too. I mean, these are really small things here. There's only like 1 or 2 millimeters of area right there. And when it comes to, you know, the thing looking weird, like I said, some of the flux from the solder could be the thing that you're seeing rather than solder itself. But again, you wouldn't know until you go in there and clean it up with a toothbrush and some alcohol. That does look a little bit cold, like there's a big blob on the side there. You know? So I'm going to have to go in there with the loop to double check. But it looks great under the loop there. So someday maybe I'll get a fancier microscope camera or something so you can see it better. All right, I'm feeling pretty good about this one. Certainly a lot better than the other 2 times I tried it. So here's the hot air here. I got this going to be set to 350 Celsius, I think. 325. Now that's pretty hot. You'll probably see the cardboard browning a little bit as this thing goes, but you'll see the solder reflow nice, and it'll get just the right shape to the fillets around those pins there. I turned it around just now because I don't want to blow hot air into the socket, because I don't want to do any more damage to the plastic inside there than is absolutely necessary. There it goes. You can see it going now. So there is going to clean up all the little rough edges on those solder joints. All right. Now sometimes when you do this, even the thing is ever so slight little tap, that can help it a little bit. I'm going to go ahead and do the other edges. Whoa. The cutting pad underneath here, this thing down here is plastic, so it's expanding and bubbling up a little bit. But I've seen that happen before. It'll all go back down when we're done clowning around here. Okay, so that should be good. I want to get that little corner there. Okay, I'm going to take it off. I'm going to let it cool on its own. I don't want to blow on it or anything. I want to let it air cool naturally, because you don't want it to cool down unevenly, right? If you blow on it, it could get really, you know, cold over here while it's still hot over there, and it could warp and do weird things. So, and the hot air was on this circuit board a long time, so the entire board, even if I touch it like way over here, it's probably really hot. Okay, so you're gonna want to leave this sit a minute or so before you mess around with it. All right, so the next thing up is the the socket for the oscillators. Now, you got a 4-pin hole here, and you got I have these 8-pin sockets. Why? Because these are cheaper than the 4-pin sockets. In the GitHub page, I have a link to both kinds, right? These are way less than half the price of the 4 pins, and they might be out of stock on the 4 pins. Now, these are what we call machine pinned sockets, right? They have these round holes. They're made by milling. They're at the top of the line. These are the best sockets you can buy. And they're probably the only ones you want to even risk using with these oscillators, because the 4 oscillator pins are actually wires, the round wires that come out of the case, rather than integrated circuits that are bent flat pins, okay? And therefore, if you put like a socket that has these kind of bent pins like this in for your oscillator, the oscillator really won't stay in very well. I think they'll kind of fall, they'll want to fall out pretty easily. All right, so I use these. Now, because I only have a 4-pin hole here, you need to remove the inside 4 pins. I mentioned this before. I talked about it on the GitHub page. What you need to do, the way I do it, is you grab a pliers and leave it open a little bit like this. Let me hold this sideways so you can sort of see what's going on. If you grab the pliers and it's open, how am I going to do this? Like this, and you take the socket, right, so that the pins that you want to remove are sitting in the open part underneath this pliers. Oh, this is fine. I should show you like this. All right, and then you take another pliers and you grab the pin you want to remove and you shove it down into the case, and it'll come out the other side. Don't pull it out this way, because the head of this is bigger than the hole. You'll destroy everything. So what I'm going to do is I'm going to just grab the pin and I'm going to, push down on it without letting the socket go flying across the room. Sometimes it's easier to use this part of the pliers over here. That's what I'm going to do right now. Okay, so push it down and it just falls out. Okay, so remove the middle 2 on each side, and it took me quite a lot of pressure to push that thing out. It's gonna fight a little bit, but it's not like it matters, because if you break it, or if you bend it over one side and you bend the pin, who cares? You're gonna shove it through and throw it out anyway. So this socket, like I said, is like less than half the price of the 4-pin socket. And if you buy a 4-pin socket, just go over to DigiKey and look at the photograph of a 4-pin socket. And what you're going to see is exactly this. It's an 8-pin socket. They haven't bothered to put the pins in the middle, and you're going to pay twice as much for that. Okay, so this now will fit perfectly into the footprint like that. All right, not bad, right? And remember, make sure that the notches line up with where pin 1 is. That's what I mean. You want to do that so that you have a nice consistent layout of the board and everything else. You don't screw up when you put the chips in. That's again why I put these giant slugs on here. Okay. Again, shout out to Fran Lab. That's her idea. Love it. So now we just solder in all the sockets. Okay, now I've got all the sockets on here. I did not put the reset switch in there because I don't really need it. I have the reset diode and the 0.47 microfarad capacitor for the reset logic in here. The rest of the reset resistors and the transistor are needed. I put the bypass caps on the CPU, the RAM, and the flash, but I didn't bypass anything else. It'll limp along without it, just to make sure that things are sane before I go ahead and solder the rest in. Mainly because these little dum-dums are real expensive. The through-hole bypass caps are shockingly expensive. And I don't have a whole lot of spares. So if this doesn't work, I'd rather not have to use up all those parts. These little 0.1 microfarad capacitors are definitely needed because they are for the charge pumps in the serial line driver. These SIPs are also rather costly, but they're all but one of them are downright necessary, or the thing won't work. So I went ahead and put them all in. I didn't actually have enough, so I had to take the hot air and pull one of them off an old Rev 2 prototype board that doesn't run correctly anyway. So I just have enough of these to get by here. So with no chips plugged in, let's go ahead and power this up and see if it is happy in that sense. I'm sure it will be, but let's make sure before anything gets plugged in there. So I just connected my USB power supply. This is ground, and 5 volts is going to be on just about every one of these chips here. Have power in the upper right corner and like ground down here. So we should see 5 volts, and we do. 5.1 volts is perfectly within the bounds of reason, and nothing is exploding, which is a good sign. All right. And we'll unplug the UART, go ahead and reprobe everything, make sure the voltage is running down, which it sort of is. You can see it going down. It's at 0.8 volts and falling. Just surprising that the USB... I'll go ahead and pull out the USB power completely here. Now it really will be down to 0. I'm sure we're watching a filter cap discharging. So we still got to have a volt in there. It's probably this capacitor right here with nothing really draining it. There it goes. Not really. I'm surprised. I'll give it a minute or two to drain. And then we'll put in some of these chips, fire it up and see if it runs. I'm sure it'll be fine. So I'm going to go ahead and populate all the chips. I guess one last note, though, before I do. Remember, this connector right here is optional. You never need to really put it on. It is a really difficult thing for even, for me to solder in. It's not the super easiest thing. So if you're not really into the surface mount thing, or not willing to, whatever, wrestle it around for 20 minutes or however long it takes to get the thing on there, then don't bother, okay? That's what this thing is for, right? If you get the SparkFun adapter, okay, you don't need any of these resistors here. You don't need this socket here, and you don't need any of these surface mount parts on the back either, because these are the power regulator and the filter caps for this socket right here. So if you don't use this socket, you don't need any of the surface mount parts at all. Okay, that's great. And you just plug this thing in like so. You don't even need these resistors here, because these exist to convert the 5 volt circuitry over here to the 3.3 volt circuitry in the SD card that we have to deal with because we're running it ourselves. If you get the SparkFun board and you want to run it like this, they have the surface mount circuitry that is needed, the regulator, and they use a chip where I use the through-hole voltage dividers to deal with the voltage conversion that's necessary. Again, for the 3.3 volt SD card. Okay, so I plugged in all the chips. They all look like they're in the right way. All the little notches are up. Pin 1s are all up there. Same with this bottom row down here. These all look good. Jumpers are same as my old board. These are on the right, which means we're not using the CTC to generate the bitrate clock. We're running directly off this crystal, so we won't be testing this, but that's okay. Just something to keep in mind. We can move them over and boot it again to check the other way. We're testing the SparkFun board, so brain dump here. I don't think we need any of those parts. Missing bypass caps. It should work without them. But once in a while, we might see some sort of an error. I mean, there'll be a lot of noise in the power on these chips. If it doesn't work, we'll just start adding them back in and see if that works. That'll be one of the reasons it may fail to boot. But again, I just leave them out until we're ready to go and commit to this release. So let's go ahead and power it up and see what happens. Well, it's mostly a good sign.